evening all. Today we will start chapter 5. Chapter 5, what does the chapter means? Continuity and differentiability. So before entering into this chapter, we will see some concepts of limits from the 11th standard. We will recall the concept of limits. So before that, just consider these two cases. So first case, we are taking this is x value, this is my f of x value. If x value I'm taking 0.9 means suppose I'm getting 4.9. Suppose x value is 0.99 means 4.99. 0.999 means suppose I'm getting there 4.999, like that. Another case, you consider that I am taking that x values as for example 2.5 means I'm getting 5.5. if it is 2.3 means I'm getting 5.1. 2.1 means I'm getting 5.001. suppose 2.01 means 5.0001. one more value we can add 2.0001 means I'm getting 5.00001, like that. So in these two cases, here consider just look at the x values. X values moving from 0.9, 0.99, 0.999. Suppose you are adding one more column means it is more precisely 0.999 can be written as corresponding f of x value is 4.9999. So now the x value is moving towards the number 1. Here f of x value is moving towards the number 5. Clear? Similarly, in this case also, f of x is value moving to 2. F of x value is moving to 5. That is, so what is the difference between them? Here the x is approaching the 1. For example, 1 is approaching from left side, that is 0.9, 0.99, like that it is approaching from left hand side. Similarly, here the 2 is approaching from right hand side, 2.01, 2.001, 2.0001. so very near values it is taking. So like that, x approaching to 1 means f of x approaches to 5 here. Here x approaches to, f of x approaches here also 5. Clear? So you can consider one more case for this question. For this second case, we can consider like that. For example, if I am taking x values as 1.9, 1.99, 1.999, my f of x suppose it is 4.95, 4.99, 4.9999 means what will happen? See that here x approaches to 1.9, 1.9, 1.92, x approaches to the value 2, f of x approaches to the value 5. So for this I am using the limit, that is x approaches to, which point x approaches to 2, my f of x is approaches to 5. That is called limit of the function. Limit f of x tends to 2, that limit is equal to 5. Similarly, in here this case, limit same x approaches to 2, that is 2.5, 2.3, 2.1, 2.01, 2.001. f of x is approaches here 5.5, 5.1, 5.01, 5.001. Here also f of x approaches to 5. But what is the difference between these two? Here the 2 approaching from which side? That is 1.9. if it is 2 is here means 1.9, 1.99, 1.99. so 2 approaches from left side. That is called left hand limit. Similarly, in this case, second case, 2 approaches from right side. Second case means this one 2.5, 2.3, 2.1, 2.01, 2.001. X approaches from right side. So in this case we are telling it is a right hand limit. It is left hand limit. So left hand limit means we have to mention a small minus in that limit. Right hand limit means x approaches from right side. It is 2 plus numbers. It is 2 minus some numbers, some h value left side of 2, similarly some value right side of 2. So it is left hand limit, right hand limit. Generally what will you say? The limit of the function definition we will write now. So the limit of the function equal to, in generally what we will say means, in general x tends to a, as x tends to a, f of x tends to L, then L is called the limit of the function. Then L is called the limit of the function f of x, which is symbolically written as, we are writing this as, which is symbolically written as limit x tends to a, f of x equal to L. Limit x tends to f of x equal to L. That is the function x approaches to a, x value approaching to a means the f of x approaches to a L. So the approaches to L means that we can say that is the limit of the function f of x at x equal to a. So as I said already, the x is a is approaching from left side mean that is left hand limit. A is approaching from right side mean that is called right hand limit. So what is the left hand and right hand limit? Now we will write it. So definition of left hand limit means that is same as limit x tends to a minus, that is a small minus should be here, f of x equal to L. That is called left hand limit. Similarly, what is right hand limit means limit x tends to a plus f of x equal to L. This is left hand limit. LHL, short, we are writing the short form, RHL, this one. So at which case, for example, if we want to find a function's limit f of x means left hand limit must exist, right hand limit must exist. After that they must coincide. Left hand limit and right hand limit must coincide. In this case, limit x tends to a minus f of x equal to limit x tends to a plus f of x, both also equal to L. So left hand limit equal to right hand limit. So we can say that limit x tends to a, f of x equal to L. So left hand limit x should exist, right hand limit should exist, both must coincide. So that case we can say that is the limit of the function. If suppose one of the limit does not exist means we can directly say limit does not exist at x equal to a. Clear? Next we will see some results of the limit. So what are the results? Some important result we will see. So results, first point, limit x tends to a, x power n minus a power n by x minus a equal to n into a power n minus 1. Limit x tends to 0. Second one, limit x tends to 0, sin x by x equal to 1. And third one, limit x tends to 0, tan x by x equal to 1. Next, fourth one, limit x tends to 0, sin inverse of x by x equal to 1. Next, fifth one, limit x tends to 0, tan inverse of x by x equal to 1. Next, limit x tends to 0, e power x minus 1 divided by x equal to 1. Next two result we can take it as, then enough that Question number result number 7. Limit extends to 0, log of 1 plus x divided by x equal to 1. Then one more result you will write, limit extends to infinity sin x by x equal to 0. So these results is enough to solve some problems of this chapter. These results which is not available in the textbook, so we have to go through this clearly. Only this first result, second result, third result only we have learned from the plus 1. 11th standard we are writing the result, we are taking the we are dealing the results. What are that? Yes, 11th standard we are dealing only this result and sin x by x this result, and one more result also we will add that. 9th result, what does that means? Limit extends to 0, 1 minus cos x divided by x equal to 0. So these 9 results we have to go through clearly. We know already studied the limit concept in 11th standard plus 1. So now we will move to the definition of continuity. So example, you just to see the graph. For example, f of x equal to 1, where it is taking 1, x is less than or equal to 0. So x less than or equal to 0, we will take the value of f of x equal to 1. The value of f of x equal to 2, x is greater than 0. Now we try to draw the graph of this given equation. We said that x is greater than or equal to 0 means it is taking 1. Sorry, it is less than or equal to 0 means it is taking 1. So less than or equal to, for example, this is 1, this is 2 means this is origin, we know that already. Y dash, x dash, now it is origin. So x is less than or equal to 0. So x less than or equal to 0 means all the value will take it as 1. So we have to draw a straight line left side. So this 0 also covering, so I am making a dark circle. Next, x is greater than 0 means it is 2. So I need to draw a small circle because 0 is not included. Right side of 0 is, it is equal to 2. So now see the graph. If you are traveling from the x values minus 5, minus 4, minus 3, minus 2, minus 1, 0, up to that the value of the function is 1. At 0, greater than 0, there is a jump here. We have to jump from 1 to 2, then 1.12, every value we have to travel this line, that is y equal to 2. So there is a jump in x equal to 0. There is a break in the graph. There is a discontinuity in the graph. This is called discontinuous. So if I want to prove a function is continuous or discontinuous, if you want to check means at every point I need to draw the graph. It is not possible or as always. So we are using the definition of the continuity. What is the definition of the continuity? So the definition is continuity definition. Suppose f is a real function. F is a real function on a subset of the real numbers, on a subset of the real numbers, and let C be the point. I am going to take a point. Let C be the point in the domain. Let C be the point in the domain F. Then F is continuous at C. If f is continuous at C, if limit extends to C, f of x equal to f of C. What does that means? Limit of the function at x equal to C is equal to value of the function. So limit of the function equal to value of the function. Limit of the function at x equal to C, which is equal to value of the function at x equal to C. If these two are equal, we can say that f is continuous at x equal to C. Clear? Suppose I am telling that left hand limit and right hand limit concept here I need to apply. What does that means? The function is continuous at x equal to c means I need to show that LHL must be equal to RHL must be equal to value of the function. So LHL at x equal to c and RHL at x equal to c I need to find, and then we have to find the value of the function. If LHL not equal to RHL means we can say that the function is not continuous at x equal to c, or LHL is equal to RHL and which is not equal to the value of the function mean that case also we can say that the function is not continuous at x equal to c. And then third case, if any one of the LHL or RHL does not exist also we can say that it is discontinuous at x equal to c. Clear? So now some results from the continuity we will see. So from the theorem we can write some results, basic results. What are that means? If f is continuous and g is continuous at the point x equal to c means we can say that f plus g also continuous, f minus g also continuous, and f dot g, that is f into g also continuous, and finally f divided by g also continuous provided g not equal to 0, that is g of c not equal to 0. G of c not equal to 0 means we can say that this f by g also continuous. So more precisely in these two cases, if any one of the function f or g is constant function means, for example f of x is equal to lambda means we can say that lambda into g of x also continuous. Similarly in this case also if f is my lambda means lambda divided by g also continuous. Clear? Okay, these are the basics of the continuity. In next class we will start the exercise problem 5.1. Thank you.